Oké, test, test. Horen jullie mij? Nee. Can you hear me? Can you hear me now? I think you can hear me. Okay, thank God. So we connected to the data space. In the meanwhile, I'm very sorry for the delay. We are about 10 minutes late, and welcome everybody for this one-day event. We just came out of 45 minutes of technical setup. So what we have been doing now is we have our presentation here. The morning session of only the morning session of this event is live streamed on Teams, on Teams, but also on YouTube. So it's actually streamed on YouTube. So I just want to let you all know that whatever you say will be on YouTube for a while. So everything that is there is there. The afternoon session of today will not be recorded, so that will be just outside and it will just be locally here. This will not be on YouTube, not on Teams, not anywhere, it's just here locally. So welcome everybody. My name is Pieter Pauwels. I'm from this university and in the Department of the Built Environment, and I'm doing this together with Ekaterina Petrova, who will introduce herself in a bit. And we want to have a data space for construction event. It's an event that we are organizing with two projects, Upscale and Wilson. Just maybe for all of us, who is here from Wilson? Can you raise your hand? Okay, Upscale? Okay. Nice to meet you also. Please mingle. We are all here in one data space. Upscale is the national project, so that's a Dutch project that we have, and the Wilson project is a European project. Wilson is more linked to IoT and smart buildings. Upscale is more about circular construction. We can see on the right and on the left those two areas. The idea that we have for today is that we look into how we can use data spaces for both IoT and smart buildings as well as circular construction. And the idea is to also look into technology in general. I will not spend too much more time. So this is our agenda for today. We have the morning until 9:40. Okay, I'm catching up with 5 minutes. After our talk, we will have a keynote, first by Frank Hermans from Tractor, who is here in front. And second from Markus König from Ruhr University in Bochum, who is also here, not in front, there, okay. Then we will have a coffee break. After that, we will have a 1-hour plenary where we will do highlights of the two projects also in this room, which will be managed by Andreas and Ekaterina. Then we have a 1.5-hour lunch, which means we have actually some time in that lunch to talk. After the lunch, we will be in 3 parallel workshops. We will explain this a bit more in the afternoon, but the workshops are also in this building, just behind that wall. So it's on that side, and we will spread separately in parallel. So you will be in one of those 3 rooms. The moderators of those 3 workshops are again Frank, who you will see in a minute, Mohamed Kassem from Newcastle University. Mohamed is there, and then Philippe Hagedoorn is here. Okay. Thank you so much. And then after that, we will have a concluding plenary, which we will probably not make too long. And after that, we will have the drinks outside, including poster session. It is just behind that wall. So it's all here in this building. I encourage you to enjoy the place, also go outside now and then, and have a nice day. Before I hand over, we have one survey that we would like to do. We don't have to do this now necessarily. We will also make this QR code available during the day in the other rooms. It's a survey about responsible research and innovation in data spaces. That's trying to see how we want to, how do you experience responsible research and inclusiveness and innovation in the context of data spaces. We will share the QR codes still later in the other sessions. Okay. And I'm gonna hand over now to Ekaterina. There you go.
Yeah, good morning also from me. I will not use that much time besides saying also welcome to all of you. We typically make the joke of this wouldn't be a technical university if we didn't have technical issues. So now I can really make that joke. So what we wanted to do today is to see whether we can not just disseminate what we are doing, but to find out whether we are facing potentially similar challenges across some very, let's say, different contexts of circularity and smart buildings, which may or not be that different when it comes to challenges in implementing data spaces. And for that, we are also very happy to have two people here that can present both the industry perspective and the research and connection to industry perspective in the face of our two keynote speakers, starting with Frank Hermans. And Frank is the founder and CEO of InnoTractor, working a lot with data sovereignty. So how do companies and people share data securely, transparently, and so on? You focus on very complex supply chains. I think we're going to see that in a little bit, actually, what level of complexity we are talking about. And yeah, quite a lot of commitment to really delivering these scalable, secure, sovereign systems that we are all looking for. I think you'll probably explain this a bit, but most recently, you can also say a little bit more about what happens in reality with PortGuard, so the Port of Rotterdam, InnoTractor, and some other partners where you formed the Strategic Asset Intelligence Alliance about critical infrastructure using data spaces in the Netherlands. So I'm very happy to introduce you, Frank, to the audience, and the floor is yours.
Thank you. Can you hear me? Better. Yeah, okay, good. Very happy to be here. I have a background in technology, electrotechnical engineering here in Eindhoven, so it's good to be back here as well. I've been in global telecoms for over 20 years, and the reason why I'm mentioning that is because you all know that telecoms became big by standardization. That's why we all now have the same global telecommunications network worldwide. With InnoTractor, I started roughly before Corona to help enterprises also use new technologies. And we've been in the data space environment now for over 3-4 years. That's why we claim to be leaders in the data space and secure data sharing activity. Now, what leaders means, it doesn't mean that we're big and that we're so good. It means that we are actually fronting the pain of all the first mishaps, unclarities, non-standards, etc. That's what being a leader is about, actually. So from a technology perspective, we are extremely excited and happy. From a business perspective, I have my doubts whether it's always good to be in the front end, to be honest. And I hope to share with you some of the experience that we've been going through the past years to really see how can we evolve these technologies in the market. What we are aiming for and why we're doing this, we're focusing really on the data aspect. So I mentioned already the sensoring part, IIoT part, where do we get the information from, but also how do we share the information with the data space technology. And on top of that, actually the real business benefits, how can we use it in the means of digital product passports or also the digital twin capabilities. That's what we as a company focus on with one goal actually, and that's on the right-hand side. If the data is available, if the data is also reliable and trustworthy and has its integrity, then we can really start with creating the next level of applications and move towards the real benefits, what can AI can bring us actually. So that's actually the stepping stone we see. Now I want to take you a little bit into the next part of that. This picture, is it familiar? Who recognizes this picture? Still a lot of arms, but still a little bit disappointing, to be honest. After all these years with data spaces, still an unfamiliarity with data spaces at some aspects. At least there are more arms actually than before, so it's growing on annual basis. That's good to see. This is the basic picture of how a data space works. I'm not going to go into the technology, but it's basically about each actor in a data space has a connector, and that connector is governed centrally when it comes to identification, authentication, authorization. So it controls what can somebody do in this trusted ecosystem of players. There are a few important elements. Identity provider is, of course, a crucial one to actually secure the roles for who is acting. But also the two I'm going to elaborate on is in the middle, you see the offer, cataloging. What is actually the offer or the data product that one user can get from another? And how do we define that in real practice there? What does that mean? And then the second one is, of course, about the bottom one, the data transfer. The data transfer does not happen within the data space, but directly between the players. And what data is then transferred and in what sense? Because that is very important to be governed then by configuring actually the policies of a user, what can be done. Data sovereignty is mentioned very often. What does data sovereignty mean? It means actually that I control who can see what data at what point in time. Yep, okay. And it also means that you control yourself who can see what data from you at what point in time. And so that policy governing is a very important element in this setup. That's how we're looking at a data space. So it's a one space where every player, every actor has a connector, just one connector. And that's the benefit, of course. If I have an ecosystem of 100 actors, I just have one connector and can communicate with 99 others there. What I have to do myself is, of course, govern my policies. Which of these 99 persons I want to communicate with, what do I want to communicate with, and maybe also what are the other governing rules around that. In that sense, this is applicable into both the public but also the defense domain. I think we as a company are now concentrated in 3 areas, which I'm going to briefly elaborate on. One is in the aerospace. I'm going to focus on that one a lot. The second one is actually what mentioned already by Ekaterina, is in logistics, in the port of Rotterdam, the harbor area. And the third one is in the manufacturing industry. That's what we're working here in Brainport together with NextGen High-Tech and SCSN to really use the digital product passports in the manufacturing industry in a data space environment. Standardization I mentioned already. The standards are there, but not completely. Even in the military space, that's the bigger one, it is already being defined and embraced, and not even many people are aware of that. But when it comes to the data space architectures, the zero trust architectures, the way of communicating, also from a NATO perspective, it's moving in this direction. And you can imagine that there are many architectural consequences then how you can implement this in, for instance, combat areas, but also in operational areas. The other one, I hope you recognize that one, that is the standard for data spaces, standardized in ISO IEC. And you see the current status under development. Actually, it's ready, but it's in the approval phase there, which doesn't mean you can't work with it today, but you have to be aware, of course, where the status is. And this has been one of our pains the past 3 years, that we were deploying, we were engineering while the standard was still being developed there. And that, of course, had its consequences, that not everything was defined. So you run into all kinds of undefined areas and have to find a solution and then see again whether the standardization committee does the same thing or re-engineer it again. So that has definitely costed us some headaches and pain and extra hours. But nevertheless, we can already still work with it and move forward. So I'm going to take you a little bit on a journey that we have in the past 3 years in the aerospace industry. And the airline industry is quite challenged, as you know, in cost, in sustainability. So one of the things the Hyperion project is aiming for is improving the sustainability by just reducing actually the whole complexity and usage of specifically the component chain in maintenance, repair, and overall. To give you an example, for each aircraft in the air, there's a 6-fold on components on the ground. And then you can imagine that the challenge is to get the right component at the right part, at the right location, at the right time, with the right people and the right working instructions and the right tools. That sounds complex, and that's exactly the challenge that they have. And you can imagine that when that's not fully digitally supported, things go wrong, which lead to too many transport areas, too much stock, etc., etc. This area is growing significantly, and we're working with KLM, which is together with Lufthansa, actually the two big players in the worldwide maintenance, repair, and overall services in the airline industry, amongst others. And as you see also, this is still growing. And the airline industry is working hard to be more sustainable, specifically also now with the Clean Aviation Program to go to more sustainable fuels, electric flying, hydrogen flying, and also other materials to get to 95% CO2 reduction by 2050 there. So there's a lot going on there. And what we're doing in that one, I'm trying to show you here, very simple.
Leads to better designs, longer-lasting parts, and smarter innovation. And for the planet, less transport, less waste, fewer emissions.
That you have when technology has to be tested.
Aircraft keep the world moving, but even the most advanced machines need care. When a part degrades or breaks down, it must be fixed, quickly and precisely. Every grounded aircraft tells the same story. Delays, global shipments, rising costs. The process is slow, resource heavy, and far from sustainable. What if we could change the game? Faster, smarter, greener. That's what Hyperion is aiming for, using cutting-edge technology to transform aircraft maintenance and supply chain control from reactive to intelligent. Imagine parts that can talk and signal when you're wound down. Hyperion uses smart sensors to monitor the health of each critical part, so action happens before failure. Each component has a unique digital product passport, a secure record of its full life cycle. Always up to date, always traceable. From factory to flight, you know exactly the status and condition of your part. And when every part is connected, the entire maintenance and supply chain becomes visible. The control tower keeps operations flowing, directing the right part to the right place at the right time. No more guessing, just smart, seamless logistics. For KLM and the Royal Netherlands Air and Space Force, Hyperion means more aircraft in the sky, fewer disruptions on the ground, and major savings in time and cost. For aircraft manufacturers like Airbus, Boeing, and Embraer, and authorities like EASA, Hyperion unlocks powerful insights and sets new aviation standards. More data leads to better designs, longer-lasting parts, and smarter innovation. And for the planet, less transport, less waste, fewer emissions. Hyperion is not just a breakthrough in aviation, it's a leap forward for sustainable aviation. Fly into tomorrow with Hyperion and contact us for more information.
As you see, this is a cooperation between multiple companies. And that's actually a very good point where a data space brings its added value directly. And you can see the analogy is probably also in the building industry. A complex building compared to a complex airplane, long life cycles, 20, 30, 40 years is no exception, with also during that life cycle many things happening there, from maintenance, exchange of components, additions and changes to the construction or setup. That's exactly the same challenge we have in the aviation industry. The digital product passport in there is of course a complex item then, because it is a hierarchy of passports. each component has a passport. Components set up a subsystem, and multiple subsystems create a complete aircraft. Where, of course, during the life cycle, a subsystem can be extracted from the aircraft and another one can be injected. So also that digital infrastructure needs to support all those activities and events in the life cycle. And that's actually the reason why we're working with the companies and also the EASA as governing entity. How do we standardize that? Because if the whole industry is working with different data models, different ways of exchanging data, we have a problem. And that's what we're doing in this project to create the infrastructure, because the data space is really the infrastructure with all the governing agreements on how and what data is transferred in what type of setup and format. So that it doesn't matter whether one company has this ERP and the other company has this ERP, that they can exchange the right data formats between each other. That's actually what the infrastructure builds its value in this infrastructure. And if you look at that, then it becomes very important to really understand why are you building this infrastructure? Because the value, with all due respect, is not in the data space. The data space is purely infrastructure. It is how is this infrastructure used? What kind of agreements and frameworks do you agree on to exchange it? Because if you look at a simple process of maintaining a component, there are a lot of interactions between the different actors to make that happen. And each of these interactions need to be actually well governed, clearly defined. So ontology, what's being used in definitions, how are the data models being used, how can it be adjusted, adapted, or actually added to, are important agreements in such an ecosystem. So managing this ecosystem, the governance, is a crucial task and actually the key success factor. The key success factor is not in the technology, it is in the governance. How do you set it up? How do you manage it from a technical, legal and business perspective to agree actually on all those elements? And that's maybe the real work to be done. So to take a simple case, we want to track a component both in its physical but also in its process flow. So you can imagine if an airplane needs maintenance, it starts with a request for maintenance. At that point, the whole flow starts to work. What component is there? Are there other components? Where are they? How can we plan actually the maintenance there? So there's a request actually to plan it, to make sure that all the information is available. Here is where the data space has its added value. If you have direct access to all your data sources, the ability to make a planning or optimize a planning is much easier. And after you've got the planning, you could start to execute it there. And also in execution, of course, you have to look at, are the right people working on there? Documents need to be filled in, actually, has the right instructions been followed in the right way with the right tooling? Has everything been certified? To ultimately get to, certainly in aerospace, of course, to an airworthiness certificate again, so that the aircraft can go back to service. So also those steps in the process, the workflow management, are elements in the data space and the governing of the different data models to be defined. So you really have to be understanding the process, understanding the actors, the way of working, and how can you come to a generic set of agreements to manage that. That's the real challenge in this endeavor. And that's how also this started with just define a DPP. And the next speaker is going to go into DPPs, but you can imagine that a DPP for a coffee machine looks different than for an auxiliary power unit or even an engine. So there are big differences, but all those DPPs need to be managed in a way. So as a DPP service provider, this is one of our challenges, to manage the multitude of DPP standards and allow the access to the right set of data in the DPP, because not every actor can see the whole DPP. You can imagine that a maintenance shop can only see part of the DPP, which is applicable to the maintenance that he should do at that point in time. This is where the data space come in, where KLM or the Air Force can give the limited, correct access to maintenance partner to execute without having to do many different things in finding out the right documents, graying out stuff, and all those different things that are happening on paper. So this is the key part. I'm going to skip this a little bit for time. I do want to highlight this one. This means actually be very aware if you work with the data spaces to make kind of a simplified view. How does this process work? What needs to be facilitated just to get started with it and get to as a guideline for how you do your agreements with the partners on the data models and the data exchange that's going to happen. I think this is really important work. And this, of course, a simplified view. And then the next step is, of course, that during this process, you're going to define what policies are going to be available. So in this case, for instance, the control tower, he has to set the policies, who has access to what data at what point in time. And the ODRL, the Open Digital Rights Language, is actually the tool for that, to automate that. So if you have the possibility from a spoken or written language to directly transfer that actually to policies that can be digitally executed, that is actually a very big gain. And that's where the policy expression language, ODRL, plays the game on the higher level, set the policies and help companies to implement that. We're going to have a quick example of that. So Hyperion today is currently more than 2.5 years underway. It's going to take another 1.5 years to actually the next milestone, and then we're going to move up. Already today, additional partners are joining actually this ecosystem, and we're building the ecosystem really by looking at the different standards. I think this is one of the challenges, but good governance is really crucial. Look at what standards are there, which ones are we going to use, and how are we going to translate that into the business logic for this process. And currently, that's the next level where this ecosystem in 2028 onwards is going to have both defense and civil companies joining us, and that gives a large ecosystem to be managed. So baseline now for the data space is really crucial to enable that. That's why we've focused on the governance architecture. And put the governance framework here, where we say that from a governing board, which has the input actually of all the key players, so not only the airlines, but also the OEMs, the manufacturers, and even the maintenance companies are represented in the board to have their say is how can this work in the best way. So from that we can look at the strategy and the marketing of the whole ecosystem, but also on the right-hand side, the compliance part of that. Thus, what compliance rules are going to be there for the actors in the data space, but also, for instance, in the airline industry, for airworthiness certification. And of course, in the building industry, you also have to adhere to all kinds of different regulations there. That's also one of the key areas. And then you have actually the 3 ones on the operational level that really are executing, where we ourselves are more the data space operator on the technical infrastructure side. But of course, you need the trust authority, identity management partners, and also the policy enforcement setups to create the business lines. That is governs then actually the purple line, where all the participants actually are playing their role. Where also app service providers, digital product passport providers, smart contract providers, other AI applications can be part of offerings in the data space. And not to mention, you really have to look at the lower level, managing the policies, managing actually the security levels. Is it compliant to all those levels? It's a governance state. And this actually is a set of, let's say, work and a team of people that, of course, needs to be paid as well. So the business model is also very important, that the actors contribute all actively and financially to actually managing and this governance model and the cost of that. So, as I said, it's an infrastructure. The infrastructure needs to be managed. So same like a building, it's important that those aspects are taken care of from day one. Otherwise, you're going to lose yourself or the financials and the business models going forward. This is applicable, as I said, in construction. And one of the things we're also doing now, where you mentioned already, is looking at other infrastructures in the manufacturing, and this one is more in the logistics part. So, for instance, what I just wanted to show you, how does this work from an end user perspective also. With PortCard, we're looking at the players in the harbor, and I cannot share too much, but what I can share, of course, simple use case of how can we ensure that all the key players, customs and authorities, can have access to the right video streams at the right point in time. You can imagine if there's an incident or calamity, that's something that needs to be managed. This is where a data space delivers his added value directly, and its flexibility, so that the body cam of a police officer can be viewed by the central administration in the port authorities, for instance, and making that possible for maybe a limited point of time during an incident. So this is how something like that looks like. Maybe give you a small sneak preview. So if I look at how such a thing could work, and I want to just show you one element. This is, for instance, a view of the harbor where you can see, and this is one of the things we did. I talked about the policy language. I talked about the core layer. On the right-hand side, you see Azure, OpenAI, and Claude, that we have agentic AIs, actually a user interface for the users, where they can directly ask their questions. Who is in the data space? The AI actually operates directly with the connector to ask questions in the data space as we have been defined there. Create the incidents there, so that there's a common view of all the players in the same way. And then you have the AI actually that works with the standardized setups. It's purely the calls directly into the data space, how they are being defined. So it gives for the end user a very intuitive view, which is the same for all the players in the data space. So there's one common view of the whole environment there. So that environmental awareness grows significantly. And this gives you a quick sneak preview how such a system can work and where the added value lies for those players. Now I'm try to see if we can get rid of this again. So yeah, there it is. Yeah. And the last example, actually, what we're doing with SCSN is in the manufacturing industry, where you can imagine that the big engines created and managed for creating steel, the steel coils, actually need maintenance as well. So together with SCSN, the Smart Connected Supplier Network, we're working on how can we standardize for the manufacturing industry that they can have actually the digital product passport based, for instance, on AAS, Asset Administration Shell, which the next speaker hopefully can introduce a little bit to you what that means, as a standard actually for managing the information. And the most important part, have a very low threshold to communicate with their larger customer base on the products that they deliver, as well as the manufacturing maintenance of those large machines. Because you can imagine every hour that it's not actually working costs a lot of money. And here we have actually now demonstrated last week in the Next Gen High Tech part, the first implementations of this. And we're working together with SCSN and TNO to also create standards also for this DPPs in the availability in the smart contract supplier network of Brainport, where currently there are already 500 companies connected. Serving multiple companies in this ecosystem in a standardized setup. Also here, same challenges. Governance is crucial. SCSN has forgotten actually to ask the customers to start paying licensing from day one. So they're now in a catch-up mode. And I can tell you that's a painful process. If nobody has paid and then when you start paying, that is of course a big hurdle. So really looking at the governance, that setup, create the right services, and the business model is really crucial to implement. I'm not going to go into the digital product passport for you looking at the time, because I think our next speaker is going to do that. But hopefully I gave you a little bit of a sneak peek on how a data space infrastructure can really add value in the working processes in both manufacturing, aerospace, but also in secure and critical asset management areas like logistics and the harbor. And our learnings in this is really dive into it, and I would say start with it, but start also with looking at the process and the standardization part of how I'm going to implement those policies further on to deliver that value. And that is something that's luckily now more and more being standardized. So I don't want to scare you off at all. On the contrary, I would like to encourage you to start using it. I think you are all aware infrastructure is where we build our economics on, and the data spaces are really the infrastructures for the future. So, thank you.
Questions? Not working? Okay.
Okay, so no, no. Yeah, I know I have to speak, but yeah. You've talked a lot about the product passport. What standard or what set of standards are you relying on in your project for digital product passport? Or did you create your own representation for that in your project?
That's a good question. The point is that many of the standards are still lacking. So we have the EU standards for ESPRL there for the whole circularity part. That's where we're starting with. But we see that in the industry that's where the limitation is today. Secondly, we're looking at the AAS, the Asset Administration Shell, being standardized by IDTA. Actually use that as a DPP standard. Problem is the AAS is not compatible with the data space architecture. So those two don't match. The data models cannot be used directly. So currently, just think a month ago, IDTA and IDSA, the Data Space Standardization and the Digital Twin Association, joined forces actually to come to a model where this AAS can fit seamlessly into the setup. So I think there are now 3 standardization organizations, OPC, UA, IDTA, and IDSA, trying to figure out how that works. And that's a little bit the pain that I was mentioning. You run into some obstacles. For instance, the AAS is a dynamic model, and that's not completely applicable when you set up such a data space setup. That's the challenge. But I think those are the standards we use. And then for the aviation, it's the same point. There is no standard how the DPP has to look like for all those components. So that's why we're working with EASA. Make sure that we can do a common agreement within that industry, otherwise it's going to be a big mess. There's still a lot of years of work to go through to come to the point of but as I said, it should not keep us from starting to that gradually work.
Maybe what's in it for you, Nuke Factor? You set up all this infrastructure.
Yeah, it's been a painful project, and we hope to get some return on investment. That's true. Our role is threefold. In this phase, we're a project member and actually also some consultants. a lot of things going on in the building sector. I think in the Netherlands, we're trying also through the government to see can we create those standards. The aspects there, and of course there have been already quite a number of companies that have been doing things. Madaster is one of them, and there are multiple others, and BIM, so that have been working on that. And I think that's the goal now, to really come to more the standardized approach that we can say, okay, this is the passport we can use for everybody. Plus, of course, you have to work in the workflow, where from the design phase of the building, you can already start working with the same infrastructure and passports that are going to be used actually throughout the whole life cycle of the building. And I think that's the work ongoing actually. How should that work? That's why I said there's big similarities between Print Aerospace and materials. There are elements to build upon, but we're not ready. Yeah, and that I think that's the same in the aviation industry, where there are planes already there without those passports. How can we gradually move into that area? I think that's one of the pains we have to go through. Yeah. Thank you.
Still preparing. You can maybe continue. Check. Yeah. Continue, of course. No. You can also stop and then we just wait. Okay, now test.
Yeah,
okay.
Very important here is that Markus played a key role in establishing the first national building information modeling curriculum for German universities. And also, just as importantly, a co-author of the book Building Information Modeling Technology Foundations and Industry Practice, which is more or less our Bible in a way.
Okay, now we can stop. Hopefully now it's working. Okay. Yeah, thank you very much. So I'm not sure if you can hear me? Yeah, that's good. Maybe online is also good. Yeah, thank you very much for the invitation and to talk about the topic where we are now working on for a while in several projects, not especially about digital product passports or material passports. Therefore, I'm quite happy that you gave us an insight also from another domain, Frank. That's therefore I can shorten also my slides a little bit, and I can maybe tell you a little bit more about the details how we try to implement it. So maybe one thing is missing in the whole CV. So I'm also the head of the Gaia X Hub Germany for construction, and I'm doing this now for 3-4 years. And so in the first year, the construction industry always ask me, what do you mean? Data space, Gaia X, whatever. We don't need it. We have cloud system. We have maybe the Autodesk cloud, construction cloud. We have CDEs. We just upload everything. And I say, no, that's not the way we want to do this. We want to store the data maybe at your company, or you use a cloud system which you can select, and where you can also move the data from one system to the other system and just grant access. Thank you very much for the introduction about the data space. And now
I think also the construction industry is really understanding what does it mean to build up a data space. And I want to highlight a little bit as I started preparing the slides and I submit the keynote title about material and product passports. So actually it's not clear what is a material passport anyway. So a product passport is quite clear what is a material passport. I try to show you my vision here. So motivation is like in the other case. I think the motivation here in the construction industry to provide digital product passports is a little bit different. It's coming more from reusing material, circularity, sustainability. So the problem if you build a building, and so if I'm not talking about the installation, about maybe concrete and all the material which we are bringing in, and then we are using this for maybe 50 or 100 years, and after 100 years we do a deconstruction and want to reuse some of this material or these elements, then of course we have a lack of information. So we are doing this now at our university. So our campus is now 60 years old, and we have to rebuild all the buildings, and it's quite a mess to collect all this information. So we have no digital information about that, more drawings and a little bit paper-based documentation. So if we are coming more to the circular economy, then of course we want to reuse all these elements, maybe again, maybe also repair it. So maybe normally we remove it. And then of course we also want to have a transparent flow where all the materials are maybe moving from one building to another building or back to the production, maybe do some recycling. And so it's all about reuse, recycling and urban mining. And there I think the digital product passport will play a big role. So this is the main motivation. There are a lot of challenges, and you addressed also a lot of challenges here. So the biggest problem is, of course, where to store this data, the product passports, who has access rights, so who can maintain it, who can adapt it, and of course we have no standards for that. And of course, how can I guarantee the quality? So if you're collecting now data and I want to reuse it in maybe 100 years, of course, if the quality is bad, maybe then, of course, you cannot use this information. So a lot of challenges here in the whole life cycle of a building product or something, or a material here. So products, of course. So it's a little bit tricky in the construction industry when we are talking about material passport or digital product passport. So sometimes we mean the same things. Sometimes we mean, okay, is the material part of the product passport, or we say we have the material passport for a building, like Madasta is doing this. They always saying, okay, I'm collecting all the information about the products, and then I build a material passport for the building where we have more an inventory of all the materials, quantities, and we can maybe have a good assessment of the building. How can I reuse parts, or how is the circularity in general? So this is a little bit my vision, that we're starting with the products, and that the material passport in the end is a little bit more bringing this together. And therefore, it's very important, first of all, of course, to model the digital product passports also for the construction industry. So that's a little bit on the product level. That can be maybe, of course, bricks, steel, windows, maybe all precast elements. So, of course, all are products, and of course, they are using some material which we can maybe extract later on for the material passport. So, why is this so complicated? If you are thinking about a window, we have a lot of different components in it. We have a structure, we are talking about the frame, and surface and something like the glazing and all the things. We have, of course, a lot of properties in it. We have information about the manufacturers, the suppliers, maybe a timestamp where you install the window, and so on and so on. And all we have to bring it together in one big, information container. So maybe we need some kind of a structure here. People are developing ontologies for that, of course, to represent all this information in a way that you also can aggregate this. And of course, we need some kind of description. And I think at the moment this is not existing in our industry. And it's not easy. Maybe it's a difference between a product window or a product, maybe a steel component or some other installations. Also here we have to figure out what is the best standard doing that. So there's another challenge in the life cycle. It's for me the collection. So you have you manufacture this product, you have maybe also maybe some material suppliers, they have to bringing this into the market, maybe you have sales and delivery, installation, operation, maintenance, everything brings parts to the digital product passport, and so it's growing. And how we can set up a system like this is growing, it's very dynamic. And of course, we have always a static view to a certain time, and maybe we have to link all this information. And now, of course, the challenge is, do we want to store it always as a complete block, as a complete information container somewhere that we're just copying everything, or we want to link this information and want to maybe get access to information when it's needed. And of course, here we are thinking about this. So if you're looking in the European requirements, there's something about you need a decentralized storage of this data. So also for the construction product passports, you say, okay, I don't want to store it somewhere central in a cloud system. It should be stored maybe decentralized, and of course maybe some information is stored as the manufacturer, and maybe you have to host the data at least for 10 years, so it's not very long. Or you have to do this maybe to bring it into a backup archive, like a trustee, where you say, okay, here you can maybe access the information also after 25 years or 50 years. So this is written in all these European regulations. And then, of course, we have to build up some kind of directory where we maybe put all the IDs, but it's more like there we store the link to the original product passports. So it's like a list of links, and you can search in this registry, and then maybe you get access to this information. This is written in the European regulations without mentioning any technology. So something we have to set up. And of course now data space is coming in. So of course we say, okay, I don't want to repeat it. So it's of course all about trust, policies, security, compliance, and decentralized storage. It's not a big cloud system where you put everything in. So we have different stakeholders, and they provide data, and maybe they also use data for a certain application. So this is a little bit what we are doing. So we started a project. I want to explain the project a little bit later. So developing a data space, and we looked into different implementations. One implementation is so-called Tractus X. So it's an implementation. It's coming from the automotive industry, from a big project, Ekaterina X. They developed an open source framework where you have all these services, all these different implementations, like a connector, like a policy hub, like So actually, we are just implementing a semantic a hub to share models and to maybe do a better semantic representation. We have discovery providers, we have catalogs, and so on and so on. So for all these different aspects, we need a certain implementation, which actually forms the data space. So the data space is not formed by the data itself; it's formed by all these services. So actually very important, as you mentioned before, so it's the policy hub where we have policy templates, where we can define access rights and how long you can maybe guarantee an access only once, many times, it's public available, or we have these connectors, very important, because in the connectors maybe the main data exchange take place. On the other side, of course, if you're now thinking about the construction industry, it's a big industry, a lot of companies. And of course, you need something like a discovery service where you look for a business number, for example, that you have some information, what kind of data is shared by this specific company. And maybe you get some meta information about the data, and then you get always the link to a certain connector where you can connect then directly and get the information. So that means also that we need something in the middle, like a portal, like a web service where you can log in, maybe can search for it. It's very important also, it's coming more from the Gaia X architecture is this self-description. That means you have to describe your service, your company in a certain way, and you have to guarantee that everything is compliant and you get the certification. And then you can also trust that this company is providing maybe good data, and you can always check it by a self-description engine where you can do some kind of checking if everything is correct. It's like a certificate in the end. So this is more or less available. So I don't want to go into detail because we saw a similar picture before. So in the end, if you set up all these federated services and all these identities and policies, then of course a data consumer maybe can ask for data from a provider, maybe using all the services, maybe set up a contract based on policies, and then in the end, of course, you establish this connection between the consumer and the provider. Both sides need a connector working with the same technology. In our project, we are working with the Eclipse data connector here, so you can set it up, and then always, if you want to perform a data exchange, all the policies are checked. Is it still valid? If everything is okay, and then the data transfer is starting. So this is a little bit the idea. It's for the implementation. It's a lot of technical overhead you have to implement to really. You need the identities, maybe wallets, the policies. Maybe you have also a logger where you want to log every transaction, every data or exchange in the end. So we are trying to set it up in a big project now for the construction industry, that in the end, of course, the users can concentrate a little bit on the applications. So then we ask ourselves a little bit in the whole project how we can exchange maybe the digital product passports. And in other domains, also we heard it before, the asset administration shell. It's a little bit like a concept from Industry 4.0, so where you say I have a certain asset, and around this asset I build a digital representation. This is the main idea. And normally you say you have some core information which you always store, some metadata for every asset. The asset can be big or smaller. You can have a hierarchy between the different assets, of course. And then you bring in different submodels. That's the idea, that you say for maybe the product representation, I have a submodel. For the maintenance, I have a submodel. For the production, for the quality control, you can integrate time series. You can integrate a lot of detailed information. However, it's always a hierarchical structure, and you can always bring in for a certain use case a certain submodel here. So this is a little bit the idea, and therefore we use normally reusable templates, that we set up a template, and then you fill the template, and then of course you can also extend the template in the end. So there, why we choose this, because there is exchange already available with our connector using the asset administration shell. So it's possible to exchange information, or also part of submodels using our connector and the asset administration shell here. So now, of course, there's a little bit, so I'm coming to this part. So of course now we're working on the implementations. Not only we, a lot of partners are doing this, that setting up submodel templates. So there are some templates already available. So there's the Digital Passport 4.0 specification for the AAS. That means they try to specify how you have to structure your AIS if you want to use it for a digital product passport. There's also an implementation for battery passports already. They have, I think, 7 or 8 submodels already defined for different applications, for different phases in your life cycle. So that's more or less done for the battery sector, if you want to maybe exchange batteries for a car. And you can directly download it from the International Digital Twin Association, there's a list of submodels. There's also one submodel which is more general for every product. You can use it, so there's only product identifier and so on in this submodel. So now, of course, that's a little bit, these are just ideas a little bit how we want to use it. So first of all, we have to think how we can create the digital passport in initial one. So actually, normally, if you are a manufacturer of a product, then you normally get some you get some material from suppliers. So that means maybe some information, some steel, some timber, I don't know, concrete, whatever. So here, of course, the idea is also maybe they have also certain material. And then, of course, this is not a product passport at all. Then you do the manufacturing, and now you create the initial product passport. So that means you normally you have an AAS type, so it's a template for a certain product. And then you, based on that, you create an AAS instance where you maybe put all the information about your product, the product number, whatever information of the production, and then you have a local, more or less local storage here of the AIS, the whole an AIS server in the end. And of course, then you need to, first of all, maybe you have to register, of course, that you now maybe can give access, maybe. If you think it's more a product where the instant is not so relevant, then maybe you give only access to the AS type, so that means the template, or you register the whole instance there in the catalog outside, that everybody can search for this certain type if you have maybe a QR code or a certain number. Then, of course, because this is the requirement from the European Union, you have always to provide a backup in a, you have to select a trustee to store your data somewhere, maybe for the next 20 or 40 or 50 years. And if everything is set up, then you have a digital product passport from the manufacturer, storing at the manufacturer side, and maybe you have a backup somewhere else. So, of course, if you want maybe to have a simple query, then of course maybe you have a distributor wants to maybe find out what is some kind of information about the product. Then normally you have a QR code scanning this. Then of course, based on that, you do the have a lookup service, a discovery catalog service, where you find the endpoint for exactly this product passport. Of course, we're checking the rights. Maybe you have public rights that everybody can access. Maybe you have some specific rights that, of course, you have to, you have to talk with the manufacturer in the end. And then, of course, you get the links to the manufacturer, and then you can directly access the AIS data. So it's normally like this. You have an AIS server with some kind of API. You have a connector. The connector is connecting the AIS server, do some querying, putting together some data, then you're transferring exactly maybe a part of a submodel as AIS compliant to the distributor in the end. If this is not available, then you have always a backup system. Then maybe the extension. This is a little bit tricky. So also the figures is not easy maybe to read. So on the other, now you are the building owner. You do the installation. And of course, here you can add some further information. For example, I install it at a certain time. Maybe I do some maintenance. So this data is stored at the building owner. Or maybe you have a system, maybe a facility management system where you store it. So part of the information of the product passport is stored at the owner. A part is stored at the manufacturer. You are not copying this to the product owner. This is not the idea. Otherwise, you can say we just use a cloud system where we always copy the information. So that means if you have a request in the end, you have to look for data at the product owner, and you have to look for data at the manufacturer. Therefore, also the building owner has to register maybe his AIS submodel in the catalog, and then in the end you bring it together. There's some kind of assembly in the end that you bring together this information, that you have a complete digital product passport in the end. Of course, this is a little bit new because you're not really owning all the data, and all the data is not available at one position or one data storage. Of course, this is maybe a little bit the extension. So then maybe when you want now to build a building material passport, it's the same. You have maybe an assessment company, maybe Madasta, I don't know. So where they say, okay, I want to create a material passport for your building there. Then you have to scan all the components. You get the data again from the manufacturer, maybe from the building owner, and then you can also bring it together, and then maybe you have a material passport where you can maybe doing a reuse assessment based on the existing data. So this is a little bit the idea. This is not so easy because normally we just send data somewhere or upload something to a cloud system, and then it's available. Okay, so that means, so therefore we are building now an open data space for the construction industry with many partners. And we have, of course, here not the product passport as a use case. We have several use cases. Also about construction cost estimation, construction site monitoring, supply chain and logistic. Now we are figuring out a little bit in which application fields we can apply or can use the data space good. And then in our case, we have a special focus also on cloud edge computing, so that we have also edge computing storing maybe on edge computers, also information. Of course, we have or need access also to this data here. So we are not alone, at least not in Germany. So we are one of, I don't know, 6, 7, 8, 9, 10 so-called lighthouse projects in different fields, also aerospace, so also health, wind, energy management. And the idea is that we all use more or less the same foundation. And this, in our case, is Tractus X. So who's not really familiar with that, so that's an Eclipse open source project with a lot of developers. There are community days. You can download everything free. It's open source. However, it's not so easy to set it up. So this is really the challenge always. It's not really working out of the box. So also in our project, I think there are now many people are trying out to set up all the components. Some are not really working. Sometimes only a reference implementation you have to extend. However, for us, it was a good start. And after now, around about 1 year, we have a small data space already running where we can register, have connectors, can access data. And so in the end, it's working. However, a little bit of effort we have. So coming to a conclusion, of course, digital product passports are very important. And I think we need this to access this data and provide this over the whole life cycle. We are using the AIS more or less as the information container. So it's more a container where you can put something in, but you have to develop your own submodels. So we have to think about what policies we need for the data aggregation, because we want to store the data on different places. And of course, we have to really implement all the connectors, identities, policies, and catalogs and everything. So hopefully in the end, we can provide something for the industry, for the construction industry, not only in Germany, also in Europe. Thank you. Yeah. So one thing is, of course, if you provide data and you want to use data, you need a connector. That's for sure. So therefore, you have to select a certain standard. So we are using the Eclipse data connector here. So the technical environment is set up that you can exchange data. Now the question is, what kind of data? What is the data format you are exchanging? So therefore, we are using, for example, in this example, not for everything, the asset administration shell. So it's a standardized data model, how you can model properties, submodels, and so on. So it's also standardized. So of course, both sides have to understand the AIS. There are open source implementations to define it, to load it, to get it out of it. However, you need, of course, some kind of import and export on the other side. The next problem is, in the AIS, you have submodels. And now you have also to standardize submodels. Maybe you can go the way that you maybe say in the submodel, oh, I'm only providing key value pairs, properties. That's quite simple. Then it's more a list of information. And there's also a standard how to define it. And then everyone can read it. of course, you have to also to agree on semantics. That's another thing. So what does it mean if I have a certain name of a certain property? And therefore, we have to build a semantic hub here in this system where we say, okay, we agree on a certain semantic in this whole domain, and everybody can now understand the semantic. We have the data format and everything. And then, of course, everything is clear, documented, and then you just have to implement the connector or the interfaces to your software systems that you can provide in AAS, and the AAS directly read by the connector and transferred. And then on the other side, you need the system which can load in an AAS again. So, however, there's a lot of implementation. Yeah.
A bit of practical question. So I can imagine that these passports are a bit data heavy for players, let's say, maybe. Especially if you want to authenticate, you would need to add some encryption, let's say string, etc. But in my imagination, this would result in quite heavy QR codes, quite dense QR codes. How would they be compatible with this? How would they be readable actually on site?
So the QR code is only the reference. It's only the ID to something. So I don't know. It's not super big. Of course, you need. So if you read it, so working in the data spaces, it's also not so easy. You have to onboard. You need an identity, of course. You need access. So you have to register your company and everything. It's not like everybody can just. Maybe you have a provider of maybe. As a service connector, it's also possible that someone just provides you the connector, but now we are setting up this in a way that you have a company and then you need an identity and everything. And then, of course, I'm working in this data space, and then I'm looking up something in the discovery service and the catalog service based on a QR code, like an ID. And then you get access to the connectors, to the links. This is a little bit the idea. So it's the QR codes are not super heavy. Maybe the data you're transferring, maybe that's getting a little bit bigger, but.
Sure, but if you want to add one more layer of security, you need to add, let's say, some encrypted string to the QR code.
Yes. Of course, you can do this. However, we in our field we of course say. So we are now, of course, not maybe in the aerospace domain or we're working with the military. When we are talking about a normal construction company want some information about a certain product, it's more or less public. So then you just scan it and get it. So if you need really some further information, it's more secure, you have to set up a policy. So in the end, both companies have to agree. And due to the identities, your wallets and identities, is you say, okay, this can access exactly this with this identity, with this wallet can access based on this policy, this data. You have to set it up in a policy hub. This is the way, of course, if you want to do this. So we have very often, of course, we have also just public data available, which without any access rights. Maybe you need only maybe an identity in the data space.
I was wondering, compared to the other use case of the data space airfield industry, maybe in the buildings we have way less live information.
Yeah.
What would be the added value of the data spaces in a scenario where you have less live data?
Yes, of course. It's always the discussion in our group. So when we need really a data space. So as I mentioned, we have also logistics and everything. Maybe there we have more live data, which maybe about the transportation and the current, where is the product at the moment. For the product passport, so the idea is a little bit more that we have this maybe 2 or 3 data providers. Maybe the manufacturer have to provide some information about the product because it's a European regulation, and maybe you want to also to store some information at the building owner. And of course, therefore, we say we have at least 2 data provider, and maybe another company want to access maybe the information from the manufacturer and want to also to access the information of the building owner to do some assessment. However, you can also say maybe just give me the data directly. It's always the thing with the data space. If you want to set it up in a way that everybody can join and can maybe work in this data space, or you say, okay, for a certain application, I just copy data somewhere and put it in the cloud system, then I hand it over. Then of course it's not super controlled, it's not super standardized. So it's always this is the big discussion in the industry, because they are always asking why I need this data space. We have some cloud system where we store everything central. Yeah, but it's, yeah, of course, I have no real answer about it. Maybe we can discuss this also in the workshops.
That's yeah, a very good point. I think this is exactly why we have the afternoon program. So please, kind of, if we can inventorize all of these things and collect them and kind of put them out, it also gets the ball rolling. Thank you very much, Markus. For the sake of time, I will conclude the first part of our morning program here.